Our next topic is multitone amplitude modulation. Here you consider multi-frequency signals. That means here we consider more than one modulating signals. Here we consider the two modulating signals, that is M1 of t and M2 of t. M1 of t is equal to A M1 cos omega M1 t, M2 of t equal to A M2 cos omega M2. Next, the resultant signal you consider M of t. That M of t is equal to summation of two modulating signals, M1 of t and M2 of t. So that is M of t equal to M1 of t plus M2 of t. So next, M1 of t equal to, we know that A M1 cos omega M1 of t, and M2 of t is equal to A M2 cos omega M2 t. So next, you just substitute this M1 of t and M2 of t in standard AM equation. As we know that standard AM equation, S of t is equal to AC plus M of t total into cos omega ct. So here AC in place of M of t, we substitute M1 of t and M2 of t. So that is AC plus AM1 cos omega M1 t plus AM2 cos omega M2 t of cos omega ct. So in this equation you just take out the AC as the common. So just AC of 1 plus here AM by, here AC is common, that is 1 by AC, AM by AC. So that we called mu, the ratio of the message signal amplitude to carrier signal amplitude, we called as the modulation index mu. So here AM 1 by AC is mu 1. So mu 1 into cos omega M1 t plus, here also we having AM2 by AC, that is mu 2 cos omega M2 t whole into cos omega ct. Now AC into multiply this one. So AC into cos omega ct plus AC into mu 1 cos omega M1 t into cos omega ct plus mu 2 into AC cos omega M2 t cos omega ct. So next, coming to trigonometric formula, that is cos A into cos B equal to 1 by 2 cos of A minus B minus cos of A plus B. So according to this formula, here we write our equation S of t equal to AC cos omega ct as it is plus here cos omega M1 t into cos omega ct is there, cos A cos B, yes, right? So that we write, that is mu 1 into AC by 2 cos of A minus B. Omega C is the high frequency, that is omega C minus omega M1 of t minus mu 1 AC by 2 cos of omega C plus omega M1 by, omega 1 of t plus, next coming to mu 2 AC by 2, next cos of A minus B, omega C minus omega M2 of t minus mu 2 into AC by 2, yes, right, cos of omega C plus omega 2 of t, yes, right? Okay. So next coming to here, we having the two modulating signals, yes, right, that is M1 of t and M2 of t. So M1 of t is less than, just consider M1 of t is less than M2 of t. So that's in that way. So here our frequency of message signal 1 is less than message signal frequency 2, that is f M1 is less than f M2, yes, right? Okay. Next coming to here we having the two modulating signals, thereby we having the two LSBs and two USBs. Okay, so four frequencies we having, yes, right? Okay. Now To draw the frequency spectrum for this equation, just you apply the Fourier transform for this equation. Then after you just draw the Fourier spectra. Yes, right? Okay. Now coming to here, Fourier transform of AC into cos omega ct is AC by 2 del of f minus fc plus del of f plus fc. Okay, so next to Fourier transform of AC into mu 1 by 2 cos omega c plus omega of t, Fourier transform is AC mu 1 by 4 del of f minus fc plus fm plus del of f plus fc plus fm. Okay, so by using these two formulas we can write our s of t in terms of s of f, that is by applying the Fourier transform s of t is changes to s of f, that is equal to AC by 2 del of f minus fc plus del of f plus fc. This is related to AC cos omega ct. Next term, that is AC into mu 1 by 2 next to cos of omega c minus omega m1 is there. Okay, so that AC mu 1 by 4 del of f minus fc plus fm is right, fc plus fm plus del of f plus fc plus fm. Next term is AC mu 1 by 2 into cos of omega c plus omega m. So same, so here its Fourier transform is AC mu 1 by 4 del of f minus fc plus fm and del of f plus fc plus fm. That's right. Next term is AC mu 2 by 4 cos of omega c plus omega m2. Yes, right. Next one is AC plus AC into mu 2 by 2 cos of omega c minus omega m2. Okay, so for that two frequencies Fourier transform is AC mu 2 by 4 del of f minus fc plus mf of 2 plus del of f plus fc plus m of 2. Next plus AC mu 2 by 4 del of f minus fc minus fm2 plus del of f plus fc minus fm2. Okay, so this is our s of t equation in terms of the s of f, that is time domain is converted into frequency domain by applying the Fourier transform. Then you draw the Fourier spectrum for this one. Okay, so first you draw our s of c signal, s of f signal. Okay, so this is our s of f signal. Yes, right. Next to locate an s of f amplitude of the frequencies. Okay, first term is related to carrier signal, so that's why we having the minus fc and plus fc terms. Okay, you just locate that plus fc for right side and minus fc for the left side. Okay, amplitude of this one is AC by 2, so you just locate the or amplitude on the s of f axis. Okay, so here I locate the AC by 2. Okay, then locate the our fc and minus fc. Okay, so left side is all negative frequencies, that is fc and fm both are negative frequencies, right side for the positive frequencies. Okay, next for m1 for m1 signal we having fc plus fm1, fc minus fm1, so fc plus fm1 and fc minus fm1. So those having the amplitudes are AC mu 1 by 4, AC mu 1 by 4. You just locate the that amplitude on this axis, AC mu 1 by 4 and AC mu 2 by 4 also. Okay, so AC mu 1 by 4. Okay, next this is related to M1 modulating signal. Okay, next coming to here also we having minus fc minus fm, 1. Okay, next coming to here, minus fc minus of fm1 is right, so that is minus fc plus fn. Okay, next related to m2 signal, modulating second signal, so that is also having fc plus fm, fc minus fm. Okay, so here fc plus fm2 and fc minus fm2. Why? Because here you see if fm1 is less than fm2, so that's why we take fm1 first, and secondly we take fm2. Yes, right. Next, for the left side also we having minus fc minus fm2 and minus fc minus of fm2, so that is minus fc plus fm2, minus into minus plus, that is fm2. So this is the frequency spectrum of our S of f for the multitone modulation.